students, I am in this screencast going to go through the quiz questions that were in Module 1 on explicit and recursive formulas. I don't have my stylus, which I know doesn't really make for great handwriting anyway, so I'm using the mouse, so it's going to be even worse, and I apologize for that. Do the best that I can. I just want to go through and make sure that you know the correct answers, as well as perhaps some reasoning behind the correct answers here. So the exam that's at the end of the second module has 33 questions. There are some questions that are very similar to the ones that you found on this quiz. So spending some time with this screencast will probably be in your best interest. So on this one, Alexis is getting terms by building off of the previous term. So to get the second term, she adds 3. To get the third term, she adds 5. To get the fourth term, she adds 7, and so on. And so basically says, hey, when she gets the 7th term, and by the way, the 7th term implies n is equal to 7, okay, because n stands for the term number, so n is equal to 7. And then if I want to say, hey, what actually is that term, I write that as a sub n, or in this case, more specifically, a sub 7. Okay, so I'm just trying to do some of the notation here. So n refers to the term number, so I'm trying to get the 7th term. So I am looking for when n is 7. A sub n, all right, is a generic way we talk about the actual term, not the term number, but the actual term. So in this case, we are looking for a sub 7. We're looking for the number in the sequence when it's the 7th term in the sequence. All right, so the way that she got her answer, she got 49, and she did so by adding 13 onto 36. And so she got her next number of 49. So the way she did this was using recursion or recursively. All right, terrible handwriting, but we'll go with it, right? All right, so she used recursion here. Just as an aside, you could also do this explicitly if you knew the pattern, okay? Alexis did not do it explicitly. I am simply talking about explicitly here to try to give some more instruction to help you guys out on that next exam. So if Alexis were going to do this explicitly, she would need to have recognized that, hey, the number in the sequence is the square of the term number. So basically, here's n, here's a sub n, right? So that's, n is, where am I at in the sequence? I'm on the first term, a sub n is 1. Second term of the sequence, the number in the sequence is 4. Third term in the sequence, the number in the sequence is 9. All right, and that keeps working. All right. If you recognize what's going on, you can say, hey, if I'm looking for the nth term in the sequence, I can get the term by squaring the term number. All right, so you can see this relationship. 1 squared is 1, 2 squared is 4, 3 squared is 9, and squared is n squared. So another way to get the 7th term would have been to say 7 squared is equal to 49. Right? And let's say I wanted the 15th term. Well, I just quickly explicitly say, hey, use my term number here, the 15th term, square it, I've got 225. Okay. I could also have gotten the 15th term recursively if I'd wanted to. It would have taken a while though, because I would have had to do plus 15, get that answer, plus 17, get that answer, and keep going until I got to the term that I needed to. It works. It definitely works. It's just a little bit more tedious. All right, so that's question 1. All right, so in doing question 1, we kind of did question 2 because this is showing us that Donnie found his answer recursively. Donnie found his answer explicitly. All right, so the answer to this one was explicitly, I think is the exact terminology it was used. All right, so he did it explicitly. So he said, hey, I want the 10th term, so I'm going to use the term number, which was 10, and I'm going to use it in this formula, and I'm going to do 10 squared plus 1, and I'm going to get my answer. Okay, that's explicitly. Now, he could have also done it recursively. I'm not saying he did. I'm just trying to make a point here of the difference between the two, so that's why I'm taking the time to do this. Would have taken him forever and a day, especially writing as slowly as I am, but you know what I'm saying. All right, so the recursive pattern, we've got a plus 3, we've got a plus 5, we've got a plus 7. I'm sure you're catching on. This one's going to be a plus 9. You'd have to do a plus 11, maybe 37. Plus 13, right? And he'd have to keep going until he got to 1, 2, 3, 4, 5, 6. So he'd need 7, 8, 9, 10. So he'd be way down here before he got his answer. But that's how he would have done it recursively. So hopefully you're starting to see the difference between recursion and explicit. All right, so next up is question 3. And on this one, we are looking at notation, and I think notation bothers a lot of people. So hopefully this will help you out a little bit, sometimes the second time through. I'm not going to say anything different than what was said in those videos, but sometimes, you know, learning is a layering process, so, you know, adding on this second layer of instruction will hopefully help. All right, A sub 1, okay? A sub 1 refers to a number in the sequence. Okay, so 1 is the term number. So the little number here is the term number. But when you put it together and you say A sub 1, I'm talking about the first term in the sequence. So here's my sequence. The very first term is 3. Okay, extra instruction here. Oops, cross that out. I want A sub 4. Right? Hopefully you know what that is. A sub 4 is, this is the first term, second term, third term, fourth term. I want the fourth term. So that's 24. Okay? So hopefully that helps you out. This is A sub 2, A sub 3, A sub 4, A sub 5, and they keep going on and on. We say A sub n when we're just referring to any old term, because n is a variable and can stand for any number. All right, so the formula here. All right, so is this a recursive formula or is it an explicit formula? Well, recursion depends on the sequence that you already have built. So you have to know the number that came before to get the number that you want right now. A sub n is the number we want right now. A sub n minus 1 is the number that came before. So this, and I'm not going to spell the whole thing out, this is a recursive formula, okay? This is a recursive formula because it says to get the number that we are on, take the number before and add 2. Right? So again, to make this pattern, to make this sequence, keep adding 2 to the previous number. Right? So now I want to know, is this correct or not? Well, if it's correct, then I should be able to say, hey, if I add 2 to 3, I get the next term. Yeah, not so much, right? If I add 2 to this, no. All right, so definitely this sequence is not built by adding 2 to the previous number. So this is not. a correct formula. Okay? All right, this second formula, I know it looks a little bit, complicated because of all of the variables and the notation, but the way that you can know that that's an explicit formula is because it doesn't refer to any terms. Okay? So there's no a sub n minus 1. There's no a sub n minus 2. There's an n, but n is the term number, not an actual term. Okay? So this is an explicit formula, and I want to see if it works. So let's say I want to find out a sub 3. So I want to find the third term. My formula tells me that I should take 3 and multiply that by 2 to the n. In this case, my n is 3 minus 1. So, order of operations, folks. This is 3 times 2 squared. Right? That's 3 times, this is critical, 4, using order of operations. So 12. Is the third term 12? Yeah, it is. All right. Seeming correct. Let's check another one. I'm going to do 1, 2, 3, 4, 5. I'm going to do the fifth. And we'll see if, this all makes sense to us. So a to the fifth, I'm supposed to take 3, and I'm supposed to multiply it times 2 to the 5 minus 1. All right, so that's 3 times 2 to the 4th. That's 3. 2 to the 4th is 16. And that's 48. Sure enough, the fifth term, 1, 2, 3, 4, 5, is 48. All right, so this is a correct formula. All right, I'm going to keep plugging along here. So the next one, I am given some information here in notation, and I'm supposed to list the first 4 terms of the sequence. So I need to be able to interpret this notation here. So remember, a sub 1 is my first term. So that's where 3 goes. My first term is 3. Right? And then here's my formula. This is a recursive formula. And the way I know it's a recursive formula is because it's telling me, hey, get the next term in your sequence by adding 5 to the one that came before. Okay, so a sub n minus 1 is the term before. This is the one I want. So when I want this second term here, I'm supposed to add 5 to this term. So I've got 8. And then I keep building from there. I keep taking the term that came before and I add 5 to it. So my next answer is 13. I take the 13, I add 5 to it. My next answer is 18. All right, that's it. I'm going to stop this screencast and start a new one.